Okay, sounds good. So we have two panelists this morning. I'm going to have them sort of introduce themselves in terms of, the year they graduated and their current job and role. So we have Allie's a project manager at Idaho National Labs, and Julia is a design engineer at TerraPower. Let's see here. Allie, let's go ahead and start with you.
Awesome. All right. So I was kind of reading through Julia's thing, and it seems like we kind of have somewhat similar overlapping backgrounds. So I graduated in 2019 and went to work for the Puget Sound Naval Shipyard as a nuclear shift test engineer. So I was the shipyard representative on board the submarines with the officers, working with them, getting reactor plant maintenance and testing done. So I did that for 3 years, and after qualifying on Trident submarines, spent some more time at the shipyard, and then wanted to move out to Idaho and stay in nuclear power because I was passionate about working in the nuclear industry. And so I applied to work out at Idaho National Labs, and now I am a project manager for the nuclear science user facilities out here at Idaho National Labs. So working with different professors and industry partners to get experiments done in the advanced test reactor and the transient reactor test facility, as well as other reactors out here, to then do research to contribute to new fuels, qualifying new fuels, as well as examining old reactor materials to see if we can extend the lifespan of current reactor plants. And I am managing the post-irradiation examination side of those experiments. So going through, once you irradiate material, you want to make sure that you can actually examine it and see what happened in the reactor. And so that's my job as I manage those projects out here.
Cool, that's great. Okay, Julia, go ahead and introduce yourself.
I'm Julia Kumpan. As Allie mentioned, we share a background at the Puget Sound Naval Shipyard. So I graduated in 2016 and went straight over to the shipyard. And a lot of chemical engineers end up in the shift test program. I did not. So I worked on the facility side as a nuclear engineer, but I still got to do all of the kind of rad fundamentals and learn a reactor type classes that they provide at the shipyard. And I definitely also developed a passion for nuclear energy. And so now I'm at TerraPower, which is a local advanced nuclear company here in Bellevue is where the office is. And we also have a lab up in Everett. And so TerraPower kind of has three programs. We have a big reactor project called Natrium, where they're converting an old coal plant in Wyoming over to be powered off of a Natrium demonstration reactor. And then we have a smaller reactor project that I'm working on, which is the molten chloride reactor experiment. And it will actually be sited at Idaho National Laboratory. I've been there several times in the last year and a half and talk frequently with members over at Idaho National Lab. So they'll be fabricating our fuel for us. And also the reactor itself will be sited at the old Zipper test facility, so the dome. And then the third project at TerraPower is actually medical isotopes. So we'll be isolating actinium-225 to use for alpha therapy, like targeted alpha therapy for cancer treatment. So, and yeah, as a design engineer, I'm in charge of the fuel handling system for our little reactor. And it runs the gambit from, doing calculations on how much pressure we need to transfer salt from one place to another, to, working with suppliers on component specifications. And I've actually learned a lot of mechanical engineering stuff since going to TerraPower. So.
Super cool. Okay, well, thank you for the introduction. So we have a set of set questions that you both have the opportunity to respond to if you want. And after we get through those, we'll move on to some audience questions. So the first, set question is, what's your day-to-day like in your current role? And then how has that evolved since you started in your job? And either one of you can jump in or not, depending on what you have to say.
I guess I can go first. My day-to-day life, I was actually thinking about this morning. One of the great things, at least in my opinion, about my role right now is that the day-to-day can be pretty varied. It kind of depends on what part of or what stage of design we're in, and also just what's going on that week. So sometimes my days are all day meetings, talking about various things. Sometimes my days are I don't speak to a single other human being and I spend all my time working on a report. And those reports can be calculations, like, I mentioned, determining transfer pressures. So, lots of math in a spreadsheet and then writing up all that math with your assumptions and your results. So it's kind of almost like being in school. And then other of those written products can be big, long system descriptions where I'm talking about all the different components and how they work together and requirements and component specifications and that kind of stuff. And so it's a good varied routine. And I think it's kind of unique to being a part of, a new design of something. So no one's ever made a molten chloride reactor before. So this is the first one. And so there's a lot of learning as you go and working on fundamentals one day and then, really establish things the next day. So, yeah.
Well, Ali, can you describe your sort of day-to-day and sort of how that's changed over time?
Yeah, it's definitely changed a lot in this position versus my old job. I am no longer getting spontaneously flown to Hawaii. It's one of the big things. But in my day-to-day life here, it's a lot of collaboration. It is a project management role, which there's a lot that is similar across any project management role, regardless of the industry. So I spend a lot of my time with cost and schedule, and then mostly working directly with the instrument scientists and the professors to really get an understanding for what they want out of their analysis. And as Julia is saying, everything is different. You're doing a lot of firsthand research. For example, like there's tests that have never been done before, and we have to design a whole new capsule and then determine safety analysis and all that to see if it's even safe to put it in the reactor. There's all sorts of new things that come up when you want to use lab equipment in an irradiated environment, and things happen that you're not ready for. So maybe if someone made a type, normal stainless steel, but they decided to use a different additive manufacturing technique, suddenly it's now 40 times higher of the dose rate than what you expected after it went into the reactor. And so stuff like that comes up all the time that you have to figure out how to address. So it does keep me on my toes. A majority of the time, though, I am coordinating with various facility managers and the instrument scientists to try and get their work done. As you can imagine, all this stuff is really old. It's hard to get new technologies approved and new processes approved in the nuclear industry. There is a lot of red tape. So it does keep you on your toes in this industry, that's for sure. You're constantly trying to do new things.
So maybe a bit of a sort of related question from the audience here. So there's a question about whether or not you work with other types of engineers, like environmental engineers, and how does your skill set from ChemE help you in this field with some of the things that you're talking about addressing in your jobs?
Well, yeah, I mean, I work with a variety of different kinds of engineers with different backgrounds. So some of them have, PhDs in very specific fields. They're very honed in on one particular instrument. But honestly, having a chemical engineering background does give you a good baseline for most engineering topics that people are going to talk about. You have a general idea of mechanical engineering, you have a general idea of chemistry, and even through quantum mechanics, you have a general idea of how nuclear power works. So a lot of it is applicable across a wide variety of fields. You will still have to do your homework, but you have a good understanding of at least how to learn what you're going to need to know to tackle whatever problem comes up that day.
Cool. Julia, you have anything to say about your ChemE skill set? How it helps you out?
I would agree with what Alice said, that ChemE just sort of generally exposes you to a lot of different things and prepares you for a lot more than it seems like other like really like specific disciplines. So, and I work with people from pretty much every engineering discipline, electrical, mechanical, lots of nuclear engineers, obviously. I guess we don't really have any civil engineers, but we're learning that we need them because there's a lot of structural stuff that we have to learn. So, yeah. Okay,
cool. And then we had a set question also related to this. You guys have a ChemE class that most closely informs your current work, or I don't know, maybe just your favorite class? I don't know.
Yeah, most closely informs my current work. I have to think about that. Do you have a good one, Allie?
I did take nuclear chemistry, but that's not quite in the not quite in the chemical engineering space anymore, I don't think. So, I mean, honestly, the capstone and like unit ops labs tend to actually really inform it, because you get random problems. That unit ops lab is old, as everyone knows. We had to fix some of our stuff with duct tape back in the day, so I'm sure that's still a problem for a lot of the students. But it does teach you the fundamentals of thinking on your feet, because things don't go right. Sometimes people's tubes explode when they're on the shaker table trying to make some fermented yeast. So you have to, it does sort of give you those tools for problem solving, which honestly is what's the most valuable thing that you can learn in college, is how to learn how to solve problems. You may not know the answer off the top of your head, but knowing at least how to start trying to solve a problem is the most valuable thing that you can learn.
Cool.
So I would say, I guess the reason why I struggle a little bit is because no one single class really necessarily informed or like helped, especially with what I'm doing now. Like the fundamentals that we learned definitely help, because I find myself having to go back and like do a heat transport problem or like Bernoulli equation calculations. Like, so you do kind of use those little things that you learned, especially in the design space. And then honestly, internships is are really valuable, because a lot of the stuff that I use on a day-to-day basis is not necessarily things you're going to learn in class. Like how to read a piping and instrumentation diagram, or how to work with vendors or that kind of stuff. So there is definitely a lot of stuff that you need to learn either through internships or like the beginning of your career. So. Yeah,
there's another audience question just popped up. So how do you refresh on sort of the material that you're not familiar with? What's your go-to? What do you guys do?
Google.
Honestly. There's a lot of good information out there on Google, it turns out. You just gotta know how to search.
Coworkers, a lot of times we have a lot of PhD students who they weren't chemical engineers, but they spent a lot of time in a lab, and so they remember how to do this stuff because they had to for practical reasons, right? So you learn that everyone kind of feels not up to it, and so you're all in the same boat, and you help each other.
Teamwork.
Yeah, for sure. Knowing who to ask questions to is very valuable, because you know that you don't know everything, and everyone also knows that they don't know everything. So knowing who's the subject matter expert on what can help you a lot. And honestly, take good notes in college, because I can tell you I've looked back at some of my old notes just to understand, like, oh, right, yeah, I did know how to do this at one point in time. Like, let me try and go find it.
Yeah.
Okay, let's see here. So we have a set question here and also an audience question that relates to it. So the set question was, what inspires you about working in the energy and environmental space? And the audience question was, you both mentioned being passionate about nuclear power. Can you tell us more about what excites you about it?
Okay, so what I've already forgotten what the set question was. Something
that question very much related. What inspires you about working in energy and environmental space?
Right.
And then specifically, you're both passionate about what excites you?
Yeah. So the energy side of things specifically, and like non-fossil fuel energy specifically, inspires me because I believe that climate change is real, which I assume that most people taking chemical engineering courses probably do as well. So I wanted to be a part of the solution. And in order to find a solution, we got to actually find new ways to power our world. And so for me, nuclear, and then especially new advanced nuclear, seems like a really great solution. I mean, obviously fusion seems like the ultimate, but in the meantime, really good advanced nuclear is a great way to, provide an excellent base load of power that doesn't contribute to climate change in any way. And then just kind of on a sillier note, I think nuclear power is really cool. When you learn nuclear fundamentals, it's cool. You kind of nerd out about it. So that's why.
Alina.
I'd agree with a lot of what Julia is saying, honestly. It is, I kind of joined the nuclear space really early on. Did an internship over at Hanford. Like Julia was saying, the internships are incredibly valuable. And that kind of got my foot in the door in the nuclear industry in the shipyard. And then out here as well, it turns out a lot of people in the nuclear industry are involved in naval nuclear power at some point. And so it does translate a lot. And yeah, I mean, it's the future. Our battery technology right now is not sufficient to allow us to just deal with wind and solar. So if we want to move away from fossil fuels, we need nuclear power. So that kind of need really drives my desire to stay in the industry.
Okay, great. All right, let's see here. So next set question we have up here. Why did ChemE appeal to you as a degree? And then the follow-up to that is, were you interested in the energy environment space before you decided to do ChemE? Or did you sort of learn about this area while you were doing your ChemE degree?
I'll let Ali go first this time.
All right. Okay. So the answer is I was interested in it. I had initially chosen ChemE because of the broad variety of topics that I could pursue. For a while there, I was in my early days really interested in doing distilling and brewing. I'll be honest with that one. It was actually part of the founding of the brewing club at University of Washington. I'm not sure if that's still going, but we at one point when I was there did found a brewing club for ChemE specifically. But then once I got into university and started learning more about nuclear power, oh, Nan says it's still going, fantastic. But yeah, once I got there, I kind of became more interested in the nuclear side of things, and it is possible to pursue a career in nuclear power without a nuclear engineering specific degree. A lot of that is through the naval nuclear pipeline. If we're going to be honest, if you want to pursue it in a different way, you probably need a PhD in nuclear energy. But there's still plenty of opportunities to pursue a career in nuclear energy and other kinds of renewable power with just a chemical engineering bachelor's degree. And so that kind of pathway is available to a lot of people, and to me it appealed because I wanted to start working right away as much as I could. So yeah, it is a broad field that you can get involved in, and honestly, the more you learn about it, I feel like the more most people become jazzed and kind of nerd out about nuclear power.
Really?
For me, so I'm not sure I put a whole lot of thought into becoming a chemical engineer to begin with, if I'm being honest. I knew, engineering is a second career for me. And I knew I wanted to go back to school for engineering specifically. And I'd always loved chemistry. And so that was pretty much how I landed on chemical engineering. But there was also a little bit even at the beginning of knowing that I wanted to be able to do something about like general resource needs. So I had my boss at the time was a sociologist, and he gave me this lecture about how, like, you know, the population is going to hit 10 billion and we're going to have enough food and we're going to have enough space to live in, but it's like all the other resources that are finite that we need to figure out how to use better. And I was like, cool, I'm going to be one of those people. So yeah, I did definitely have like a energy and environment bent to my interest in ChemE when I first went into it. And although I will say that the extent of me pursuing that was taking the energy and environment course, and that was about it. But so maybe I could have done a better job of really pursuing it. But I'm where I wanted to be now, so works out in the end, I guess.
Okay, cool. So that relates pretty well to a couple of audience questions that came in. So one was, is your current job the same as what you wanted to specialize in when studying ChemE? And then a bit related to that is, what do you consider your journey to where you are now in engineering?
So short answer is no. No, I'm not necessarily where I am where I wanted to be when I was in school, but that was because I did not know where I didn't have any idea. I knew generally I wanted to work in the, energy environment, better resource management kind of field. I ended up at the shipyard right after graduation because they were hiring and because it sounded cool. Working for the federal government's not really that cool, in my opinion. I only lasted about 2.5 years. But after I got the shipyard and got interested in nuclear, yes, like I found out about TerraPower because actually my dad is an optical engineer and he used to work on lasers, and a bunch of his previous coworkers ended up at TerraPower. And so my current position is the result of probably about like 3 years of effort of, making connections and applying to jobs, and, building up background at in a different company. Air pollution control was where I was working on. But like, I am very happy to be where I am now, and excited and plan on sticking around. So.
Cool. Allie.
Yeah. So I knew initially that I did not have the patience for a PhD, but still wanted to work in nuclear power. So I did use the shipyard as a stepping stone for that. I will say where you are in the shipyard does vary a lot on what kind of career opportunities you may have. But a lot of the time, if you do want to work in nuclear power, either a PhD in nuclear engineering is required or experience in the nuclear industry. So I kind of went the or route and gained some experience, got qualified on nuclear plants. And then while that job was what I wanted at the time, which was not a desk job, I was on my feet in a submarine every single day. So it was a little bit different than a traditional chemical engineering job. And I gained a lot of valuable experiences from that. But now, I mean, if you'd asked me when I was graduating if I was going to be a project manager, I probably would have not said no. Like, I had no idea that was a career path where I would end up. But honestly, it's just a matter of taking the opportunities that present themselves to you and having a general idea of where you want to be and what you want to do and pursuing that. So regardless of where you are in your career, you always have the opportunity to really buckle down and make some connections and try to move to where you want to be. So whether or not that's a super clear, like I would like to be a scientist working on this exact project for this exact company, or I want to generally start doing this and sort of reaching out to people, whether it be through LinkedIn or connections through alumni or anything like that, to work towards that goal. That's kind of how I ended up over here. I wanted to work in nuclear power, and I also wanted to live in Idaho. So those are kind of what brought me to where I am now. But yeah, I mean, it depends on what you want. So depending on where you feel like you're at when you're graduating college and where you feel like you're at however many years you are into your career, your goals kind of change and shift over time. And so not really getting super locked down into I want to work right here is kind of good because you maintain some flexibility and you can adjust your strategy over time to get where you want to be. And so your first job may not be your passion project, but it could be a stepping stone to get you where you want to be. So
okay, yeah, that sounds great. I'm going to try to pair again a set question with an audience question, somewhat related. So this one, I don't know if you necessarily have an answer to. Were there any non-curricular activities that you participated in that were energy, environment, or sustainability related? So sorts of extracurriculars, like did those exist for you? And then the audience question, so that may be a yes or a no, right? But the audience question is related to what you were just talking about with, you both mentioned internships, right? So how did you find labs or internships like back in college, or what opened up those doors for you?
So as a short answer, for the first question, no, I didn't. I was working while I was in college too. So my job wasn't at all related to energy and the environment. I was a martial arts instructor while I was in college. That's how I paid my bills. So I didn't really have a whole lot of time for other extracurriculars. But as far as internships go, there was a email I remember from Nicole that had a internship offer for Hanford. And so I will keep my gripes with the federal government's programs to a minimum, but I did not find out that I had that internship until a month before the school was over. So I was about to start working for Professor Stuve as a lab assistant, and then got the offer for that internship. And then from there, everything kind of spiraled out. The rest of my career was basically built entirely off networking. So I would say internships are incredibly valuable, even if you're not there for that job or that field. Use the networking opportunity to try and get yourself where you want to go. So that's kind of how I ended up where I'm at
now. Yeah, my short answer is no as well on the extracurriculars. I know there was like a biodiesel club, I guess is the best way to put it, while I was there, that kind of piqued my interest, but I didn't feel like I had the bandwidth necessarily to participate. I will admit that since I was a post-baccalaureate, going into a second career, I was, in terms of like getting internships, I was able to stand out from the crowd a little bit with the fact that I actually had a resume at that point with, like working experience. So luckily that appealed to people. But in terms of finding internships, yeah, it was all through the department. Our department does a great job of letting people know about internship opportunities. And my two internships were actually in pulp and paper at, pulp mills, which had nothing to do with what I wanted to do with my career, but they are very bread and butter chemical engineering experiences. So that's good. Like, you learn how to walk around a plant and, follow a pipeline, or like what a condensate line is. And so it's very good practical experience. Yeah.
Cool.
So.
Yeah. Okay, so we're getting more questions from the audience here. So I'm going to go with a couple of those. Did you learn any skills on the job that the university didn't prepare you for?
Going back to that practical application thing, one of the first couple of weeks of my first internship, we were going to go learn how to do lockout, tag out. and we walk up to what was a pump. And I had no idea what a pump looked like. It was just this hunk of like plastic and metal that looked nothing like what I would have envisioned a pump looked like. So there are a lot of things, especially like in terms of a plant, that you learn from internships or your first job that we definitely don't learn in school.
Okay. Allie?
I mean, I totally agree with what Julie's saying. It's all well, fine and dandy to see a bunch of drawings and do a bunch of computer simulations, but until you're there in person, you have no idea what you're talking about. And like, you'll finally get to the plant and you're like, oh, I can't even reach that valve because it's facing this direction or whatever. Like, there's tons of problems that you don't think about when you're just designing something on paper that then could come back to bite you in the butt later. Like, I had one very specific experience where we didn't even consider the fact that we would need mechanics that could fit in the hole where the pump was. So it's things like that that you don't even think about when you're initially designing everything. And it may look good on paper, but until it's real and in person and you've seen it and you can understand how it works physically in that space, it's a different kind of perspective. And that's hard to do when you're just in a classroom. You don't really have that perspective until you're there in person. And that's kind of a flaw across a lot of engineers, is they don't take the time to go actually see what's going on. And so that's something I would encourage everyone here to do, is regardless of what engineering discipline you pursue, go see stuff in person, because it's different in person than it is on paper.
Okay, a couple more audience questions here. We have women in STEM. Are there hardships? And what's the gender makeup at your current company?
I can tell you for a fact, I have been the only woman in the room on multiple occasions, especially when I was working for the shipyard as a ship engineer. I was the only woman in my test house. The joke was that I was the she-TE instead of the SD because I was the only one that was female. So yes, the gender makeup is heavily male dominated. I remember we were very thrilled when the shipyard got to 20% female. So that was a huge milestone. As far as the lab, it varies wildly across disciplines. It is more diverse, but there's also just, it's not all nuclear energy. They have, they're trying to deal with charging electric cars wirelessly. So there's tons of different teams across the lab that have various gender makeups, but overwhelmingly, yes, in STEM, it is male dominated. And honestly, on a day-to-day basis, you don't really notice, in at least my experiences, I haven't really noticed or cared. People treat you like a person if you are respectful, and most people in the field are very respectful. So long as you are good at your job and you're good at communicating, it doesn't really matter.
Yeah, it's funny, actually, at the shipyard, I had the opposite experience because I was not a ship tech engineer. So both the positions I held at the shipyard, I think our groups were at least 50% women. So that was great. And I learned to very much value my female work friendships, because it's just a little bit different than being friends with your male colleagues, at least for me personally. And then in between shipyard and TerraPower, I was a company called LDX Solutions, which I was on the air pollution control side of the house, and I was the only woman on the team. And I really enjoyed my team members. They were great guys. But you still feel a little bit isolated. TerraPower is a pretty good mix. I would say we're probably about, my team at least, is about 30% women. And definitely, no problems. Like you have some characters on your team that kind of steamroll everyone, not just women. So, you have to deal with stuff like that. But I do have colleagues at TerraPower who are on a different team who have had trouble specifically because they were women. It's clear that they are not respected by their male colleagues, especially usually older male colleagues. So it's not gone. I've never personally experienced it, but I've heard plenty of stories, unfortunately. And I mean, but you hear stories about it where it's starting at the university level, and I certainly never experienced that at University of Washington. I hope no one else does. But so like I had a coworker who also a chemical engineer. I think she went to school in Colorado somewhere, and she had a professor who straight up told her that women didn't belong in STEM. Like he's like, oh, I'll teach you because you're here, but I don't think you should be here. Like, so I've actually just recently stood up a chapter of a professional organization called Women in Nuclear at TerraPower. So I never necessarily thought of myself as fighting this kind of fight, but I have found myself in that position. So it's brand new. So we'll see how it goes.
All right, thank you both for that. Another audience question says, was there ever a point in time in college that made you question if engineering was right for you? And if so, how did you continue through?
I'm gonna have to go with no. So, I mean, there was definitely some times where I was really tired of all of the math homework, essentially. Whatever thermo, any kind of long, like solve the problem 3 hours later, solve another problem. But I can honestly say I never necessarily doubted, wanting to be an engineer. It was just sort of normal student fatigue.
Mm-hmm.
So.
Yeah, I mean, I'm pretty similar to Julia. I committed to chemical engineering in high school. I did the Running Start program, and so got a direct admission to the chemical engineering program at UW because I'd already decided that's what I was going to do. And I've kind of, at least me personally, I have an attitude of I'm going to commit to this. I'm going to see it through, regardless of how tired I may be at any given day. There were definitely days where the short homework assignment was 18 pages long, but I'd say that for majority of the time, you are going to face moments in college where you don't want to keep going. And a lot of the things that help is just committing to it, see it through. You can always change your mind later. I'm sure as Julia will tell you, you can switch careers later on in life and it'll be fine and it will benefit you later because you do have a resume. So I would say see it through. And at the end, if you don't want to do that, you don't have to do a traditional chemical engineering job with your chemical engineering degree. You can go on and do other things. So just kind of keeping that mindset of you've committed to it, see it through, and then you can make changes later. It will probably benefit you in the long run no matter what. So.
Okay, another audience question. What engineering project have you worked on that you are most proud of?
The one I'm working on right now.
That's awesome.
Short answer. I mean, everything goes well. 2 years from now, we'll start up the very first molten chloride fast reactor. So I'm quite proud to be on part of that project. So.
Yeah, I mean, the one giant positive to being a ship-test engineer was the ability to see the direct results of my work. I have done over a dozen reactor startups, so it's always a great time when you can see like all the repairs that we did. We can actually go start up the reactor and the submarine could go out and do its mission and defend our country. Like that's super rewarding. Here at the lab, it's incredibly fun to be like, oh my goodness, we got our test results for this brand new fuel qualification. We can now see like, you can see the advancement of nuclear science in real time. So that's one thing that I would find is like all those projects have been super rewarding is when you actually get to see I'm making progress in this field, however small that particular progress may be. I will say that makes this field incredibly rewarding because you can actively contribute to the future of nuclear energy in the country. So, but yeah, I had one particular, I was right before I left the yard, I was flown out to Pearl Harbor to do an emergent repair on a submarine, and being able to actually fix that reactor after. Oh God, I was working 16-hour shifts through the 4th of July week for days on end. And at the end, when you finally get to see that submarine leave the pier, that's what's like, that kind of stuff is always super rewarding.
Super cool. Okay, I'm gonna keep going with audience questions here. And I would maybe open this up beyond nuclear. The question is, what does sustainable engineering mean to you?
That's kind of a broad question.
Very, very broad question.
Honestly, for me, it's understanding that the work that you're doing is contributing to, in the future, advancing our energy sustainability, regardless of what field it's in, whether it be through solar panels or wind or battery technology or nuclear power. Understanding that you are actively trying to get us away from carbon emissions and trying to do things in a way where we're not, relying on minerals that are running out, from whether it be cobalt or other minerals that we need to sustain our battery technologies, is that you're actively trying to try and figure out new ways to make our impact on the earth as small as possible.
I would add to that in that, so we need these technologies and these ideas to sustain society, as Ali pointed out. But we also need to make sure that the ideas themselves are sustainable, if that makes sense. So a good example is one of my current coworkers. He actually UW grad in material science, and he went on to found a startup that was like one of these pyrolysis ideas where you can burn anything and make alternative fuels, and it works really well on paper. No one has managed to actually stand up one of these plants because they are way too expensive. There's always like these little nitty gritty things that don't work out. And I think he worked at that for about 5 years, and I think the company's still going, but like they were getting nowhere because, they'd get to the point of working with clients. But then as soon as they got to like, well, this is how much it's going to cost to actually build this thing, it would fail. Mm-hmm. So, and I'm not saying that what I'm working on is like super cheap. And it certainly has problems, especially in the material world, actually. But like, so we need to not only have great ideas for how to, create power with alternative fuels, but we need to think about whether or not they're actually practical, whether like they'll happen, right? Mm-hmm. And one of the things that Ali brought up, like to make sure that you're not using precious metals that are going to run out, or with like wind and solar, even if we did get battery technology up to snuff, we would have to like industrialize huge swaths of the countryside to make enough power with, solar panels and wind turbines. And that's not something that I think personally is a great thing. So you have to kind of think of like the big picture and practicalities in terms of sustainability, mm-hmm. I think.
Okay, that's good. Yeah. So I'm going to just really quickly try to combine these last two set questions, and then we'll do a couple rapid fire questions since we're running short on time. So this relates to what you were just talking about. Like, what do you see as the current biggest challenge in this field, and why is it critical for chemical engineers to be part of that effort? Ali, go ahead.
Red tape. I'm going to be honest with you.
Okay.
The primary problem with the nuclear industry as it stands right now is the insane level of bureaucracy. And as a project manager, that's my job, is to cut through all that red tape and get all that paperwork processed. And let me tell you, it eats up a large part of my day. And so that's kind of where the main struggles are with the industry right now, is the process is convoluted, to say the least. You have so many governing bodies with their own standards, and you need specialized people to even, just package up a small piece of radioactive material and ship it from one building to another. That's $30,000 right there. Like, it's crazy expensive. There's crazy amounts of red tape involved. And so that's currently the main problem with the industry as it stands right now. And I'm sure Julia, working on the new reactor, has tons of experience with all the fun regulatory issues that this industry has. That's currently where it's at. And so we need people not only to innovate ideas, but to try and make processes smoother, because that's where the bulk of the spending is, honestly, is overhead costs and administration. It costs a lot of money to pay people to do all this paperwork. So
Julia, you have any thoughts here?
I can guess what we're talking about from Ali's response, but I actually didn't catch the question. I'm sorry.
Oh, it was just what you think what do you think the biggest challenge in the field is, and why you think it's critical for chemical engineers to be part of that effort?
Right. Okay. I definitely agree with what Ali said. There is definitely, and especially in the nuclear industry or in any, let's broaden it, energy and environment, any kind of new idea, there's going to be a whole lot of momentum against it. So how could chemical engineers specifically help with that?
Why should they be a part of that effort?
Why should we be a part of that? Because I think that chemical engineers are, maybe this is just, because we all like our own, discipline better than everyone else's. But I think that we have a much more well-rounded education and view of things than the average engineer or even the average person, right? Like, I just feel like the chemical engineering, at least at UW, is like big perspective learning. And so, I mean, that's going to help, with anything, especially with trying to push new ideas forward. And then in terms of like advanced nuclear specifically, or any kind of new technology also, there's a lot of people think tanking on paper, and they're all the PhDs from MIT who are like, ooh, this is my cool idea. They need people like chemical engineers to actually make that idea happen, because we're a bit more practical. So
super cool. Okay, I think we only have like 1 minute left. So we had some rapid fire questions. And I'm just gonna go with one of them here since we're out of time. This is just supposed to be like a 1-2 word response, so super short. You have a habit that contributes to your success? What's the one thing that helps you get through?
Write stuff down.
Write stuff down. Write stuff down. Okay, that's a good one.
I'm gonna go with that.
Write stuff down. Okay.
I can't tell you how much I forget.
That's a good one. Take notes. There you go.
Okay, that's awesome. Well, we're at time, so I want to thank our panelists, both of you, for joining us this morning, and I want to thank everybody for coming. And also, I want to remind everybody to complete the reflection survey. So thanks again to all of you.
We'll give a round of applause in here for all of our in-person. Thank you, Ali and Julia.
Thank you for having me.
Thank you.